a video about simplifying fractions, and I'll go through it hopefully very fully, but you'll find lots and lots of shortcuts. But I'll do it explicitly as possible. Sometimes it's called simplest or lowest. Some people use form. Doesn't really matter. Well, you choose what you like. The concepts I'm going to use are prime numbers, which we've practiced a lot. I'm hoping that you're quite confident with prime numbers. Concept of factors, and another concept, anything divided by itself is equal to 1. An example of that would be 6 divided by 6 is 1. So we're going to use those ideas in simplifying fractions. Have you ever noticed that here's my fraction, 5 over 8, 5/8. It looks very similar to the division symbol, except for this has dots, this has values or numbers. Well, reality is they're both exactly the same. 5 over 8, or 5/8, is actually the same as 5 divided by 8. The 5 replaces that dot, the 8 replaces this dot. That is, 5 is the numerator, 8 is the denominator. And since something divided by itself is 1, if I had, for example, 3/3, which is 3 divided by 3, as shown above, then something divided by itself, 3 divided by 3, is 1. Now, most of you have picked it up pretty quickly, I'm sure, but there it is anyway. Let's now look at simplifying fractions, and we're going to look at a technique here. There'll be a couple of pages here, it'll go on a bit while. For example, if I had 15 over 20. Now I use factors, I'm using the concept of factors, and I take it to the side and I look at 15. I like factor trees. I'm using factors and prime numbers to make a prime factor tree. Very simply, I try to break up my 15. I work with 15 first. It doesn't matter if I work with 20 or 15, it makes no difference. I break it into its prime factors, and I know that 3 times 5 is 15. Now my prime numbers, well, I'll list them over here for clarity. There are 2, 3, 5, 7, 11, 13, 17, 19. They're, of course, theoretically an infinite number, but I'll leave those few there so you can have a look at them. So these are both prime, and I'm very pleased about that. I'm going to work with my 20. Now, surprise, surprise, I'm going to be a bit ridiculous here, but I'm going to be very explicit. Now, if I take my 20 and carry it the same process, you'll notice that 20 equals 2 times 10. Now, 2 is prime, which is lovely. I'll bring it back down. I'm looking for primes. And 10 is not prime, but it can be written as 2 times 5. 2 is prime, 2 is prime, 5 is prime. Checking my list, 2s and 5s, no problems. So now I'm going to rewrite, and from our last video we know about multiplication, we're sort of going backwards. And 15 is 3 times 5. Now, my 20, written over here, I write it down as 2 times 2 times 5. Using the concept of multiplication, I can see that this is actually 3 over, sorry, I won't do that bit near there, ugly. And then multiply by 5 over 5. And you can see I've just split it up as I can do from my previous video. 5 over 5. Now 5 over 5, or 5 divided by 5, as shown here, is equal to 1. That is equal to 1. So it leaves 3 over 2 times 2, and 3 over 2 times 2 is 4. Finished. Now, I've done a lot of work here for really no great value. I would expect that eventually you'll move from there straight down to here. And that's the most simple and lowest form we can put 15 over 20 or 15/20ths into, 3/4. Does that make sense? Another example. I'll copy this piece of paper. And I recommend this until you get much better. You'll find it very easy. Okay. Prime factor trees, very useful. Very useful when you get to algebraic techniques as well, this system. example number 2. Let's take, for example, 24 by the ruler over 36. Now, remembering what I'm doing is ridiculous, and you can take lots of shortcuts. Now, 24 on my factor tree, break it up. And it's good to practice breaking things up into factors as well. And it doesn't matter where you start. I might start at 2 times 12 or 8 times 3, whatever one you suit. 6 times 4 is fine, so I'll try that. There are many factors as we've been playing with. I notice they're not prime. My prime numbers again, just to remind you. And there are many others, I'll stick with those few. That's not prime, so I can break up the 6 into 3 times 2. Now 4 is not prime. Notice I'm multiplying, bring that down there as well. And breaking everything up just very slowly and clearly. 2 times 2 is 4. So I can say 24 really is in its prime factor form, we say. 3 times 2 times 2 times 2. I'll do the same with 36. 36, over here, breaking it down. And you could start with 2 times 18, 3 times 12, 4 times 9, 6 times 6. Whatever where you start is your business. That makes no difference to the end product. Because I'm lazy, I'll start with 6 times 6, because I'm very lazy today. Not prime, not in my prime number section. 2 times 3 is 6. And you'll learn these as you go through. And of course 6 again, multiplication, 2 times 3. So it's 2 times 3 times 2 times 3. So that means I can rewrite this. Now I'm using this, there is my 24, there is my 36, and I'm going to rewrite 24 over 36 in its prime factor form. 24, there it is, 3 times 2 times 2 times 2. Go over here. 36, 2 times 3 times 2 times 3. Now, interesting enough, I'm going to take a bit of a shortcut here. I'm not going to regroup them, but I can see that there's a 3 there and there's a 3 there. 3 divided by 3 is 1. Some people say cancel, or actually is 1. You can see why they can cancel, multiplying by 1. I match this up, a 2 there, there's a 2, only 1 to 1. The 2's cancel if you like. And then I have another 2 there, which I cancel. They're all 1. Leaving on the top, I just have a 2 left, and the bottom, I have a 3. And that's finished. 24 over 36, or 24/36, is actually 2/3 in simplest form. I hope that made sense. Best of luck. Enjoy it.